Here are solutions to quiz 3 for Math 111. In the first problem, we're asked to express the domain of this thing in interval notation. Alright, to figure out the domain, we have some rules. The only one that applies here is we can't divide. Did I just misspell divide? Yes, I did. Can't divide by 0. In other words, 2x squared plus 11x minus 6 can't be equal to 0. So we want to figure out what x's will make 2x squared plus 11x minus 6 equal to 0. Let's solve this equation right here. A couple different ways to solve it. Guess and check is one method. Another method is to, where do I go here? Find two numbers that multiply to a times c, negative 12 in this case, and add to b, 11 in this case. So let's see, we want to multiply to negative 12 and add to positive 11. I think positive 12 and negative 1 will do the trick. And then we're going to replace 11x with 12x minus 1x. So we get 2x squared plus 12x minus x minus 6 equals 0. And we haven't solved it yet, but we've changed it from 3 terms to 4 terms, which will be easier to factor. Factor by grouping. Look at the first two terms. Greatest common factor is a 2x. And we're left with x plus 6 from the first two terms. And we have to factor out something from the next two terms so that we're left with x plus 6. That something is a negative 1. And now we can look at these two terms and from each of them factor out an x plus 6. And we get to here. So then we can solve by saying, alright, if this times this equals 0, either the first one equals 0 or the second one equals 0, that is either x equals negative 6 or x equals positive 1/2. Whoa, 1/2. So if you think about, maybe I need to keep that separate. If you think about what we did over here, we found the two numbers that will make the bottom equal to 0. Those are the two numbers that cannot be in the domain. So that is, our domain is everything except negative 6 and 1/2, which we can write in interval notation as everything from negative infinity all the way up to negative 6, but not including negative 6, union everything from negative 6 all the way up to 1/2, but not including 1/2, union everything from 1/2 up to infinity. So this right here is our final answer. Okay, it gives us a function asked to evaluate this difference quotient, similar to what we did on the perfect problem, except we don't have quite as many steps. We can do that. We can say, alright, I know g of x is equal to 3x minus 5. What I need to know is what's g of a. It's easy, just change the x into an a. And g of a plus h. A little bit trickier here. We want to change the x into an a plus h. The parentheses are important because we had 3 multiplied times x, so we want 3 multiplied by this entire a plus h. That is, g of a plus h is 3a plus 3h minus 5. And now we can evaluate this difference quotient. We can say g of a plus h is, I just said it, 3a plus 3h minus 5. And from that we want to subtract g of a. We want to subtract 3a minus 5. Again, careful, make sure you use parentheses. We want to subtract all of g of a. We want to subtract this whole thing. And we want to divide that by h. So what we have is 3a plus 3h minus 5. If we distribute this negative in, minus 3a plus 5 all over h. Which gives us the 3a, and then maybe I need a new color. 3a and negative 3a cancel out. Negative 5 and positive 5 cancel out. And so after all that, all I have left is 3h divided by h, which I can simplify to just 3. Maybe I throw a box around that, and I'm finally done with question 1. There's kind of a lot going on there. The good news is this one's a little bit quicker. This time we're given the graph of a function. It says express the domain of this function in interval notation. The domain of a function is just the shadow onto the x-axis here. It's kind of all of the possible x values, all of the x values that have a height associated with them, which is kind of everything I colored in here in green. And what I want you to note is -3 works and 2 works because these circles are closed on the end. So my domain is everything from -3 up to +2, and it's important that you put these closed brackets on because we want to include those 2 endpoints. Okay, the range. We can figure out the range also by looking at the picture. It's a little bit different. The range is the shadow onto the y-axis, so it's kind of the lowest point all the way up to the highest point here. We have something that has a height of, it looks like about -3, and then all of these heights, there's some sort of x that'll give us every one of these heights, and it continues all the way up to, it looks like 4 is the max here, or something pretty close to 4. Call that good enough. So it looks like my range goes from -3 on the low end all the way up to 4 on the high end. And the question says, does h of 2 equal 1? Why or why not? The answer to this is a resounding no. You can figure out h of 2. What h of 2 is saying is this function, when you put in 2 as the input, what output comes out? Another way to think about it is, what is the height of this graph when x equals 2? Well, x equals 2 right here. So 2, 1 would be up here. This is this point. 2, 1 is not on the graph. So because that point's not on the graph, what we know is that h of 2 does not equal 1. We could figure out what h of 2 equals. It's the height when x equals 2. It looks like it's -3 in this case. But you're not asked to do that, just to explain why or why not, which I got over there. And that is the end of the quiz.